Are you ready?
Yes, please.
Okay, that's good. Sorry for being late. I thought we had to meet at 12 o'clock. And when I got the information that we are meeting now, I had it difficult to join. So sorry for that.
All right, sir.
Okay. Now, as you know, the course is the intro to linear, or intro to algebra and calculus. So if you have gone to my LMS, I do know that some of you have gone there. I've uploaded the book or the model there for you to go and upload it or download it. And then today's slide is also there. So when you go to my platform, you see all of them, and it is on to you to download everything and go through it. Has anybody seen it?
Yes, sir.
Yes, sir.
So have you downloaded them?
Yes, please.
Yes, sir.
Oh, that's good. Have you gone through them?
Yes, please.
Yes, sir.
So how it is? The book is very good, very good, very simple.
Yeah, it's self-explanatory.
Yes, sir.
Self-explanatory, yeah. So my name is Dr. Anthony Kwarteng. I authored that book with Dr. Stephen Okra. And you have made it very simple for you to understand it. So please, if you haven't downloaded it, go to my platform to download all of them. Thank you very much. Okay, so we have the algebra. And the first aspect that we're going to do now will be the algebra. We are now going to go through the number systems, the real number systems, and so on and so forth. And you can see the slide, eh?
Yes, sir.
Yes, sir.
Okay. So the number system that we have, as we did at the lower level, let's say at the primary school, GHS, and then SHS. It's the same thing that we are going to do here. But since we have given you a very nice and simplified book, I'm just taking you through some aspects, and the rest are for you. You know, it's a distance program, and for that matter, you are expected to do a lot of work on your own, and we'll be guiding you. That's why we are giving that book. Very good, very self-explanatory, and you have a lot of activities there for you to get try your hands on. Is it okay?
Yes, sir.
Yes, sir.
So today I'm taking you through something aspect of Unit 1. Yeah, Jonathan.
Yeah, sir.
Jonathan.
Please. Yeah, please. Good one.
Show your hand, please. If you have a question, you can ask now.
Okay. Please. The LMS. I still don't have my login.
Morning.
Yeah.
Any
Hello.
question?
Yeah, please. I said the LMS. I still don't have my portal login.
Then there's the issue that you may even trash with the center. Are you okay?
Hello?
Have you paid everything? Did you register?
Yeah, I've registered.
Have you registered?
Yes.
Have you registered the course?
Yeah, I've registered the course on my portal. I've registered everything.
Jonathan.
Yeah. Hello.
Oh.
You know.
You can hear me. And then you have to go to the office for them to do it for you. Are you okay?
Okay. Okay.
Go to office for them to do it for you.
Okay.
Are you Are you in Accra?
Yes, please, I'm in Accra.
Are you in Accra?
Yes, please, I'm in Accra.
Yes, you can come. You can come to the office for them to do it for you.
Okay.
Okay. So we are on the very normal systems, and as I've made this slide, it's very simple. It's very simple for you to get understanding. Okay. So let's move on. If we are talking about the real numbers, you know that Jonathan is okay. Let's move on, please. We know all the numbers that you know on this page.
Please, we can't hear you.
Hello, sir.
Hello, sir. Sir, please, we can't hear you.
Hello, sir. Please, we can't hear you. Please, we can't hear you, sir. Your microphone is muted, sir. We can't hear you.
Sir, please, we can't hear you. Your microphone is muted, so we can't. Can you please unmute your microphone so we can hear you? Sir, please, we still can't hear you, and you are still teaching. Like, we actually can't hear you.
Wait, is he still teaching? Because I mean, I can't hear anything now.
Yeah, I think he's still teaching.
Hey, Charlie.
Shock, sir. It shock me, sir. Hey, Eddie,
Okay, sir, I guess. See that name.
Hey, Charlie, so what's up?
So wait, but others they hear him or like we all know they hear him. So it be like we all know they hear him.
Nobody is here. Nothing is coming in.
Me, I
Hey,
don't know.
Charlie.
I don't know whether maybe just they show us the video of what maybe he's about to teach or something like that. Because me, I know they hear.
No one
Maybe
is here.
maybe because
I don't know where I'm sorry.
Charlie,
I don't think he can also hear us too.
But wait, to where is the class rep? I just want to clarify something. Is still on the line? Or is there something that you can do
Yeah,
about it?
yeah, I just called him. He said there's an issue over there, so they are working on it.
Okay, that's fine.
Yeah.
I think you should give him some few
about
minutes.
the class this thing.
Can you hear me now?
This
Can you hear me?
yeah,
we
yes,
can
we
hear
can
you.
hear you.
Yes, sir, we
Can
can
you
hear
hear me
you.
now?
Yeah.
Yes, sir.
Yes, sir.
Okay.
Yeah, we can hear you, but your voice is too far.
It's okay. It's okay now.
No,
Can you hear me now?
Yes, we can hear you.
the word is
Okay.
far away.
It's far away.
Yes, sir.
Charlie, how do?
Is it better now?
It's manageable. It's manageable.
I'm coming.
Okay.
It's okay now.
Yeah, I guess it's now okay.
Okay, that's good. Yeah, sorry for that. There was a problem here. That's why I was trying to reconnect. Okay, so as I was saying, the number that we use, we have other numbers apart from the real numbers. Are you okay? Now, real number starts from. Please try to mute your microphone. All of you, mute your microphones. Yeah. If you have a question, can you raise up your hand and then we move on? That's good. Yeah, truly.
Yeah, thank you, sir. But I think we missed the beginning of the class, the explanation. So if you can please start with that again, sir.
That's where I am.
Okay, thank you, sir. Thank you.
Okay. So I'm sure you know natural numbers, which is also called counting numbers. Is that not true? Do
Yes,
you know
sir.
natural numbers?
Yes, sir. We know.
Good. What are natural numbers? Let's hurry up. What are natural numbers? Yes. You say you know, so tell me something. What are natural numbers?
There are numbers starting from 1 to infinity.
Good. There are numbers that start from 1 to positive infinity. Is it okay? I want to get a marker so I can write something for you. So you can start it from 1 and then we end at positive infinity. That's natural numbers. So for natural numbers, if you want to go through the history of numbering, for natural numbers, if you add or if you include 0 to the natural numbers, so you have 0, 1, 2, 3 going. Are you okay?
Yes, sir.
Then
Yes, sir.
we call it whole numbers. So to me, we have a natural numbers, which is the initial number that our people maybe made or invented. And we normally call them, that's why we call them natural. They are the first symbols that our forefathers invented. And they did this one in order to count their properties. So these natural numbers are also called counting numbers, but we use them in counting. Is it okay?
Yes, sir.
Good. So if we include 0 to it, then we don't call it natural numbers because 0 is not part of natural numbers. When we bring in 0, then we call it whole numbers. We call it whole numbers. So whole numbers also start from 0, 9, 1, 2, 3, 4, 5, 6, and so on and so forth. Is that point okay?
Yes, sir.
Yes, sir.
Then when we move from 0 to the left side of 0, the right side of 0 now becomes the whole numbers. Are you okay? Or natural numbers. Now the left side of 0, there you are getting the negative of these whole numbers. So when you put the negative whole numbers, positive whole numbers, and then 0 together, we get what we call the real or integers. Richard, any question? Richard, I can see your hand. Any question?
No, sir, it's a mistake.
The slide is off. Let me also share it again. So if you are talking about the integers, now it includes positive whole numbers, negative whole numbers, and there's 0. Are you okay? So that's why the
Yes.
integers. Let me share it again for you too. Oh, the problem again. Can you hear me?
Yes, we can hear you.
Yes, please.
Yes, we can hear you. I think we miss him again, or
Yeah.
Yeah. We lost him. Hey, Charlie, what's all this? Charlie.
This is very disturbing.
They make you just log out the lecture, say, because this one.
Oh, gosh. Introduction to information system.
Can you hear me?
Yes, please.
Yes, please.
Yeah,
You can hear
I'm
me.
having problem here. That's why. Okay. 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 That's good. So as I was saying, if you include the negative part of the whole numbers into whole numbers, that starts from 0 up to positive infinity. If you go to the left side of 0, if you are doing a number line, please let's mute our microphone. Okay. So if you have a number line, when you go to the left side of 0, that these are the negative numbers. So when you put the negative whole numbers and the positive whole numbers and 0 together, we get what we call integers. We have all of them in the unit 1. They are very, very self-explanatory there. Then if we also include the fractions of integers, if we also add the fractions, either negative fractions or positive fractions, we get what we call the rational numbers. So if you are talking about the real number system, now this is how it is. We have the real number, which is a combination of the rational numbers and irrational numbers. But if you are talking about the rational numbers, as I've just said, it's from natural numbers. Now we have the whole numbers. From there, we can find all the natural numbers there. Are you okay?
Yes.
Then we have the integers. From there, we have all the whole numbers also inside the integers. I get my point. Did I get my point?
Yes.
Now, when you have the
Yes,
integers,
please.
now we put integers also into rational numbers. And that rational number, that means it consists of integers. Integers also having whole numbers. Whole numbers also having what? Natural numbers or counting numbers. Therefore, if I talk about the rational numbers, I mean the natural numbers, whole numbers, and what integers, and then the fractions. Is that point okay? Is that point okay?
Yes, please.
Yes.
Now, when you go to the model, you see what an integer is. You see what a rational number is, and so on and so forth. But just briefly, I just want to introduce you to that rational numbers or the real numbers. Now we say the rational numbers are numbers that can be written as a fraction. It's okay, but not every fraction which is to be a rational number, then both numerator and denominator must be integers. Both numerator and denominator must be integers. Other than that, it's not a rational number. We shall be looking at this down there. Now, other part of the numbers which are not rational are called irrational numbers. They are called irrational numbers. So if I combine irrational numbers and rational numbers together, I'll have what we call the real numbers. The network is not helping. Not helping at all. Should I continue?
Yes, sir.
Yes, please.
Good. So if you put rational and the irrational together, now what is the irrational number? Yeah, Jonathan. Jonathan, I saw your hand, or it is a mistake again.
Please, a mistake is a mistake.
The mistake is okay. Let's move on. Now, if what is an irrational number? We say that rational numbers are numbers that can be written as a fraction of integers. But what is an irrational number? It means that if I have a fraction whereby both of them are not integers, it could that maybe numerator is an integer, but the denominator is not an integer. It's not a rational, it is a rational number. Or if I have no integers, for both numerator and denominator, it is an irrational number. Are you okay? Now, the common irrational numbers are the square root of non-perfect numbers. I'm sure you know non-perfect numbers.
Yes.
If you don't tell me, let's so that we can move on.
Yes, you know.
What are perfect numbers? What are perfect numbers? Yes. Say you don't know perfect numbers, which means you know perfect numbers. When the number is perfect? Anybody? So you know non-perfect, but you don't know perfect. Can you hear me? Can you hear me, please? Wow.
We can hear you. I can hear you.
The rest, can you hear me, please?
I
Yes.
can hear you.
You can hear me. And
Yeah,
answer my
we can hear
question.
you. We can hear you, but just that it's not stable.
But the network problem, yeah. You can hear me now.
Yes, we can hear you.
Good. It's the network, eh? If we are not able to go far, we find time to meet. Maybe in the course of the weekdays after work. Is that okay?
Okay. Okay.
Yeah, because today
That's okay.
we not start early. Yeah, so wherever I only take my time for you to understand the concept. So let me plug it small. Whenever we get to within the course of the week, we find time to meet after work. Even though I'm very tired, but I'll find time for you. It's okay?
Yeah, sure, that's okay.
Okay, that's good. So what is the perfect number, please?
Okay, sir, can you say that a perfect number is a positive integer?
When you come to the question, you cannot hear me. What is a perfect number?
Yeah, sir, can you hear me?
Yeah, I can hear you.
Yeah, I'm saying that it's a positive integer that is equal to the sum of its proper advisor.
What is a proper advisor?
Can you say the number that divide, excluding the number itself?
That is a proper number or perfect number. Okay, you have said something. Who again? Okay, we are all learning. Okay. Actually, we are learning. Today is just introductory. Aqua. Aqua, eh? Come on, Aqua.
Perfect numbers are numbers that can be expressed as a sum.
Come out with what you have.
Please, can you hear me, sir?
Come again. I can hear you now.
Okay. So please, perfect numbers are numbers that can be expressed as the sum of their factors, including the number itself.
Okay.
Hello,
No
sir.
problem.
Sir.
Yes. Yes.
A perfect number is a positive number. Hello, sir. A positive number.
Yes, sir. Hello, sir. Can I please speak?
No, somebody was on the line.
I said a
Come again,
perfect
please.
number. A perfect number is a positive number that is equal to the sum of its proper factors.
The sum of its what?
Proper fractions.
Proper fractions.
Okay.
Okay. Yes, gentlemen. You wanted to say something? Let's move on. Okay.
Yes, sir.
You have said something. Yes, Talk, please.
Okay, so a perfect number is any positive integer that is equal to the sum of its divisors. So we can say 6 is a perfect number because 1, 2, and 3 are divisors of 6. And we can also see that 28 is a perfect number too, because it has 1,
Okay.
2,
Okay,
and 3 that
don't
are
worry.
divisors.
Don't worry. I like your class. Everybody want to see something. Even those that you meet them face to face. Some of them, you go there, they don't want to even answer anything. They don't want to ask any question. But you are doing well. Even though whether you know it or not, you don't want to see something. That's good. It's okay? Are you okay?
Yes, sir.
Yes, please.
Today is our first. But the fact is, after here, go through the model for unit 1. If I were you, I would go to before we say we are going to meet within a week days, before that day comes. Because the definition you are giving to the perfect number, you are confusing yourself. All your definitions are geared toward what's called the composite numbers. Now, let me put it short in this way. Now, you have a number line. Or you know the natural numbers? No natural numbers.
Yes,
You know
please.
the God, which are 1, 2, 3 up to positive infinity. So let's start with 1 squared is 1 squared is what? So 1 squared is what? You have calculator, square 1 for me. Yes.
1 square is 1.
1 square is 1. 2 square is what? So write that 1 somewhere. 2 square is what?
It's 4.
So write it. 3 square is what?
9.
9.
4 square is what?
16.
16.
So see all these numbers. Five, 36, 49, 64, 81, 100, and so on and so forth. Are you okay?
Yes, sir.
Okay.
These are called perfect numbers or perfect squares. They are obtained by squaring natural numbers. Is it okay?
Yes, sir.
Good. So when we take make a microphone for you. So when we take out all the perfect numbers from the natural numbers, the rest are called non-perfect numbers. Is it okay?
Yes, sir.
So can you give me an example of non-perfect number?
2 square root of
No, non-perfect number, natural number, non-perfect number.
2.
Or 6 square.
Now you perfect number. Take away all the perfect numbers. The rest are non-perfect numbers. So give me any example of non-perfect number.
2.
2 is 1.
3.
Move on. 3 is 1.
3.
Yeah.
5.
5. Yes.
8.
6.
8.
8. And so on and so forth. Are you okay?
Yes.
Yeah.
Good. I'm taking my time this morning for you. If you take a square root of non-perfect number, it is an irrational number. It's okay?
Yes.
So if you have a root of 2, it's irrational. Root of 3, it's irrational. Root of 5, irrational. Root of 6, irrational. The network is very bad here. I don't know why this morning. So root of all non-perfect numbers are called what? Irrational numbers. Are you okay?
Irrational numbers. Okay.
Now we know the irrational numbers. Are you okay? Now,
yes.
How can I know that a number is irrational? If you compute or you change that number to the decimals, just you calculate it, use your calculator, and convert that number into decimals. For irrational numbers, their decimal equivalent will never terminate. It will end, to never end.
Be like my network Tiago.
It's from him.
Shall it not be you, Perry?
You know be you. You know be you. Like be like say
Charlie.
from his side.
Everyone, please, 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 please. Are you here? Please, are you here?
Yes.
Are you here?
Yeah, we can hear you now.
Yes.
Can you hear me?
Yes.
Yes, please.
Can you hear me?
Yes, sir.
You can hear me.
Yes, yes, we can hear you. We can hear you. Loud and clear. We can hear you.
The network is very bad, very bad, very bad, very bad.
It's okay
So
now,
we
sir.
shall meet. Yes, we shall meet. Don't worry. We shall meet again. So let's move on smooth. We are closing at 11, eh?
Yes, 11.
When are you?
11.
11:15.
Can you hear me? Good.
Yes.
So let's move on. We meet again. So if yes,
Oh God. This is very disturbing.
Yo, what are you brushing teeth for them?
That person for sure that's it.
Now the person is brother.
So after this class, which class is there again?
It be break time.
Nah. I don't mean like break time there why we did this thing. I don't mean say like after this one, which other one? Like how they do them? So I know say that when we do that basic this thing. So the next one is math. So tomorrow too is the same thing or what? I don't know. I don't understand that.
You know, get the timetable. It be information system after that will be 1:45. Information. Then the last class
Okay.
will be critical thinking and reason. That will be 3:50 p.m. to 5:30 p.m.
Okay.
Then Sunday be only 3 course we go do. The digital studies course that will start from 11 a.m.
Okay.
Yeah. Then after that one, then the introduction to structured program design. Then the last one will be English.
Okay. Thank you.
Yeah, can you hear me? Can you hear me?
Yes.
Yes, please.
Hey, I asked a question and I don't know whether you were having problem of. You can hear me now.
Yes, sir.
Please, we can hear you.
Yes, we can.
The network is very bad. Very bad. So I was asking you that compute square root of 2 using your calculator. It's okay. It's okay.
Yes, please.
So compute it for us to see what we're going to get. What is root of 2? Because 2 is a non-perfect number. What is root of 2? Now, when you compute the root of 2, you could see that you are getting decimal digits, which are not ending. But because we are using calculator, it can take only up to 10 digits. But we are using the phone calculator, so it can take more than that. So those with the normal calculator that can take only 10 digits, when you get to the 10 digit, it will do approximation. And you may think that it has ended. No.
Okay.
So to go on and on, it will never end. And these digits will never also terminate. Then when we have a decimal digit that terminates, or digits keep on repeating themselves in a specific order, that number is a rational number. But if it's neither terminating nor recurring, it's called what? Irrational numbers. And I give you an example of irrational numbers as what? Square root of non-perfect numbers, squares. Is that one okay?
Yes.
Good. So if you put that rational and irrational together to give it a rare number system. So that is the diagram. So you have rare numbers that consist of rational and irrational. And the irrational and irrational are disjoint. They have nothing in common. They don't intersect. So that ends for the irrational. But for the rational, it goes down to integers, whole numbers, and natural numbers. Okay. Now, let's move on to properties of real numbers. Properties of real numbers. Now, the first one we are going to talk about is closure property. Closure property. Now, if we say that real numbers is closed, it means that when you operate any real numbers, any two or more real numbers, either you are adding, you are subtracting, you are dividing, whatever you are doing to them, you still get a real number. Is that one okay?
Yes.
When you say the operation is closed, it means no matter what you do to the members within, you still get a member who is within that word group. So real numbers are closed because whenever you operate on any two or more real numbers, either you're using addition sign or you are using subtraction, multiplication. If you multiply two real numbers, you get real number. If you add two real numbers, you get real number. If you add 10 real numbers and so on and so forth, you still get real numbers. Therefore, we are saying that a real number is what closed. That's what we call the closure property. It means when you take integers, it's closed, natural numbers are closed, and so on and so forth. Are you okay?
Yes.
Specifically, we have the closure property applied to the operations of addition, subtraction, multiplication, and division, including division by zero. But you can't divide any number by zero, but you can divide zero by any number. Are you okay?
Yes, sir.
So now, excluding what? A division by what? Zero. When you divide a number by zero, you get either you give math error or undefined. If you are calculator, divide any number by zero and see. That's why it's not a real number. The crucial method does not take that end. Good. Yes. So apart from dividing a real number by zero, whatever you take operation, addition, subtraction, you get a real number. That's what we call the crucial property of real numbers. I hope that it's okay. Now, example is this. 5 minus 8. What are you getting? -3. It's okay? And this -3 is a real number. 5 is a real number, 8 is a real number, but when you operated using minus sign, you are having what? Negative number, which is also a real number. 4. Okay. Now 4 times 6 is 24, which is a real number. 15 divided by 3 is 5, which is a real number. Root of 3, which is a rational number, and it is a real, plus root of 12, which is also a rational. Oh. A very bad network. Very, very bad. Very, very, very bad. But let's move on. Whenever we end, we meet again. So root of 3 plus root of 12 is the same as 3 root 3, which is also real number. So whenever you go, whenever we create any two real numbers, apart from dividing the real number by 0, we still get real number. That would go the quotient method. Okay. Now, commutative property. Now, if I have a number A, which is a real number, and I am operating that A by B, which is also a real number, whatever I get, if it is the same as interchanging the position of A and B, now you have B operation A. If I still get the same answer, then we say that the operation star is what? Commutative. So whenever you are taking operation on real numbers, some of the operations now will be what? Commutative. Not all of them. Some will be commutative, but others will not. So if you look at the addition, if I have 4 plus 5, what's the answer?
9.
9. Now 5 is the first number, 4 is the last number. I have gotten 9. What about 4 plus 5?
Also 9.
The
So
same
really
9.
we are now interchanging the position of what? 5 and 4, but we are still having the same number. Therefore, we say that addition is not commutative on real numbers. Is that point okay?
Yes, sir.
Good. Now let's see 8 minus 7. What 8 minus 7?
1.
1. Now let's interchange the position of 8 and 7. We have 7 minus 8.
Negative 1.
Negative 1.
Negative 1. Are they equal?
No. No,
No.
please.
Are they equal?
No, please.
No, please.
1 and negative 1. Are they the same?
No, please.
No, they are not.
No.
They are not the same.
So since we interchange 7 and 8, okay, since we interchange 7 and 8, we are getting different answers from. It's okay, let's move on. Let's move on. It's okay. Since we are getting different answers by interchanging the position of these numbers, we say that subtraction is not commutative under real numbers.
Okay.
So that's the commutativity property of real numbers. Now you say addition and multiplication are commutative. Addition and multiplication are commutative, but subtraction and division are not commutative. Explain the above properties. How can you explain this? If you know, raise up your hand, please. We are saying that addition and multiplication are we have just seen the addition 1 and subtraction 1. So, but we are saying that division and multiplication are not. Oh, the multiplication is not commutative, but division is not commutative. How do you explain this? If you know, raise up your hand. Yes. Thanks.
Yes, sir. The addition and multiplication are commutative because once you change their position, you still get the same answer. But the subtraction and division, once you change the position of the numbers, you get a different answer.
Are you sure? Are
Yes,
you
sir.
sure?
Yes, sir.
Are you sure?
Yes, sir.
Yes, sir. Yes.
10 times 5 is what?
50. 50.
Hello, sir.
It's here pass inside again.
Is he on the line?
Subtraction and division.
Are you around? Can you hear me now?
Yes, sir.
Yes, please.
Yes.
We shall close very soon. Network today not favorable at all. So let's wrap up what we have just done. So as we are saying, I was even asking 5 times 10 is what? And we had that problem. So 5 times 10 is 50. 10 times 5 is also 50. Therefore, multiplication is also completed, but division is not. Are you okay?
Yes.
Okay. Now let's look at the arithmetic. Now, if I have 3 bare numbers, which are termed as A, B, C, and I have 2 operations, but they are the same operations at the start. So if I have A operation into bracket, now this operation can be addition, it can be subtraction, and so on and so forth. Okay. So A operation to bracket, B operation C. Now here the bracket are for the second and last numbers.
Okay.
It's just one operation sign in between. Now when you go to the left side, the right side, the brackets are for first and second. So we have interchanged the position of the brackets. If we are still having the same answer, then we say that the operation star is associative. Example, 5 plus into bracket 4 plus 7, which is 16. Now into bracket 5 plus 4. 5 plus 4 is 9. Is it okay?
Yes, sir.
Plus this 7, which is what? 16. So you could see that even though we interchange the position of the bracket, we are still having the same answer. Therefore, we say the operation plus or addition is associative. Is that point okay? Is that point okay?
Yes, please.
Yes, sir.
Now let's see this one. What is 8 minus 7? What is 8 minus 7?
8 minus
What?
7, 1.
1. Then
1.
let's compound that with this. 1 minus 6.
Minus 5.
Minus 5.
Minus 5. So answer the left side is minus 5. Okay, that is I. Let's go to Ivy. Go to the bracket, bottom of bracket first.
Yeah.
So 7 minus 6.
1.
1.
1. So
Yes.
this is 1. Now 8 minus 1.
7.
7. So 7.
Okay. So is I equal to Ivy?
No, sir.
No.
No, sir.
No. If no, then we say that subtraction is not associative. It's okay.
Yes, sir.
So the question is, what's your view on the above operations? So addition is associative, whereas subtraction is not associative. I think it's okay. Now we can do the same thing the multiplication and the division. So we have addition and multiplication are associative, but subtraction and division are not. Explain the above properties. So can we explain them? We can even explain by even citing an examples. Okay, you can give an example for each. 2 times 3 times 5. Group them in bracket, first 2 bracket, and the other one, the last 2. Are you getting the same answer? If yes, then it means multiplication is associative. If not, it's not. And do the same thing for division. So we have distribution or distributive property. That's why I want to see if one operation can be distributed over another operation. If one operation can be distributed over another operation. Okay. Now, I think there's issue here. I wrote in the definition. It's what? You're talking about what? It's the same RCT. Okay, I have to make that changes for you. So for distribution, I can use maybe plus, and maybe if here it's plus, here is also multiplication. Then if you can get the same, but it is RCT. No. It can never be so. It can never be so. Okay, so I made that correction for you. When you meet other can tell me so that I'll go over for you. Are you okay?
Okay,
Yes.
sir.
Okay.
Now the time is not on our side. It's even up. What do you have next?
I think it's a break time.
Okay, then let me you get 5 minutes from me. Are you okay? So we are closing at 9:20. It's okay. Do you agree?
Yes, sir.
Yes, please. Yes.
Get 5 minutes.
Yes.
Get 5.
Yeah,
So
just 5
9:20.
minutes.
Yes. So it's even 4 minutes now. Then you have identity property of real numbers. Now, if you are talking about identity, if let's say I have a real number and I operate that real number on any other real number, and I'll get the same real number, like A operation E. It's the same as E operation A. That's the commutativity. I'll still get A. If I operate a number on different number, I still get the same number. Then you say that number that you operated upon with is an identity element. Are you here?
Yes, please.
Let me give you an example. 5 plus 0 or 0 plus 5. What's the answer?
5.
5. We have added 0 to a number 5, but we are still having the same 5. It has no effect on it. Are you okay? So there 0 is what? Identity element. Is that point okay?
Yes, sir.
Yes, sir.
And since we added, we call it additive identity. Additive identity. So if I want to add any number to a number to get the same number, that number must go to 0. Then when I multiply a number by 1, let's say 5 times 1, what's the answer?
5.
Okay, 5. So nothing has happened to 5. Is it okay?
Yeah.
So 1 has no effect under the multiplication. 5 divided by 1 is what? 5 divided by 1 is what?
5.
5.
5.
5. So we say that addition or the multiplicative identity is 1. So when you multiply a number by any number, you get the same number. Therefore, the multiplicative identity is 1. I think that point was okay.
Yes, sir.
Now, example is 5 plus 0 is 0. 0 plus 5 is also 0. And negative 3 over 4 plus 0 is this what? What is the result? Are you here? Can you hear me?
Yes,
Yes,
sir.
please.
The result. I made mention of that. It's additive identity. So 7 times 1 is 7. E times 1 is E. 1 times pi is pi. So what is 1?
Okay,
Identity.
Huh? Multiplicative identity.
Identity.
So the time is up. So we are at the inverse property. Right? Good. So we are at the inverse property. Remind me when we meet.
All right. So.
Then you continue from that end. Now, all these properties we are talking about, they are for all real numbers. So they are for natural numbers, all the properties, natural numbers, rational numbers, irrational numbers, all these properties we have talked about, they are for all of them. So therefore, when you are using a model, then you go to under natural numbers, you start from commutative, associative, and so on. When it comes to integers, so the same thing. So we are just summarizing everything here. So that when you go there to be just additional what maybe knowledge. So thank you very much. Even though we were having issues, we have done something small. But we are going to meet in the course of the week, as I said. So that we'll be in contact, discuss with your people when to meet in the evening, in the course of the week. Is it okay?
Yes, please.
So discuss it with them and give them the feedback. Now, the first meeting, how do you assess what we have done? How do you see mathematics, algebra? Is it too difficult?
Not too difficult.
Okay, what you have done is not too difficult. Are you okay?
Yes.
We thank God that you have understood what we have done this morning. To get something small. But go through the slides. No, the model and the slides. You have the slides, you have the model.
Yes,
go through them.
yes.
To understand
Okay,
everything well. Thank you very much for coming.
Right.
See
Thank you, sir.
At the next meeting.
Welcome.
Thank you, sir.
Okay.
Word. At break time, Anna.
Yeah, I think so. At break time.
Where's now?